My name's Brian Hopkins. I work here at the University of Mississippi, and specifically, I run an organization called the Mississippi Center for Supercomputing Research. There are math problems that are so difficult that they would take that same modern desktop or laptop computer many hundreds of years to solve. Simulation scientists, instead of going into the field to take measurements, what they do is construct a model of that system inside a computer. And then they can manipulate that model in various ways. The job of a simulation scientist is to take complex physical phenomena of some type and cast it in a language that a computer can understand. The best thing that simulation scientists do is work hand in hand with people who do experiments. Use the simulation to build a better experiment. And that's the case whether we're talking about a simulation of an auto crash, simulation of the action of a drug molecule in your body, a simulation of flight of an aircraft. Whatever you might think about simulating, one of the very best things that you can do is think about how you would use that simulation to guide an experiment, and how you would use the experiment to guide further simulations so that you can learn more and improve your technology faster than you otherwise would be able to. Essentially what a computer can do is add, subtract, multiply, divide. We use both one-step and two-step equations every single day.
Hey, don't worry about him. He said one and two-step equations. I know how to do those. Oh, you don't? Okay, let's learn about it.
For today's lesson, we're going to be going over one-step equations. Now, to solve a one-step equation, do the inverse or the opposite of whatever operation is being done to the variable. Keep in mind that whatever is done to the variable must be done to the other side of the equation. For example, to solve an addition equation, use subtraction. On the other hand, to solve a subtraction equation, use addition. Now that you've seen a few sample problems, take a moment to try the next two problems yourself. Wow! Let's see how you did. Since x is being divided by 4, we do the inverse or opposite of what is being done to the variable. Therefore, you should have multiplied both sides by 4. If you got x equals 24 for your answer, then that's absolutely correct. For the next sample problem, since x is being multiplied by 3, you should have divided both sides by 3 in order to isolate the variable on one side of the equation. If you got x equals 6 as your answer, then that's just dandy. I love the sweet smell of success in the late morning to early afternoon. How's about we move on to two-step equations? Solving two-step equations requires the same procedures as one-step equations. Pay careful attention to the order in which the procedures are done. It makes a difference. Be sure to do the inverse operation for addition and subtraction first. Then, once that's taken care of, do the inverse operations of multiplication or division. Let's take a moment and work this problem. 5x minus 9 equals 31. Did you get x equals 8? Let's review. Step 1. Add 9 to both sides. When you do, you should get 5x equals 40. Then, for step 2, divide both sides by 5. When you do, you should get x equals 8.
What we do as simulation scientists is take those equations and use them to describe complicated things.